times 5 times my final speed squared plus 5 times 10 times 10. Working through the fancy math here, this is 1500 equals 2.5 VF squared plus 500. I'm trying to get VF by itself, so I need to start getting rid of all the hangers on. So the 500 is the easiest thing to get rid of, so just subtract it from both sides. So I got 1,000 is equal to 2.5 VF squared. Now I have to get rid of the 2.5. How do I get rid of it? So I end up with VF squared is equal to 400. How do I get rid of the square? So I end up with a final speed of 20 meters per second, which is what we had the first time. Wow, the same answer. Real questions before I potentially come up with an easier way?
What is under the equal sign?
That's supposed to be in meters per second.
Oh, okay.
Okay, do recognize that is the final speed, not the final velocity. Now we had, this 1500 here is the amount of potential energy we had to start with. 500 is the amount that we had at the end. So the difference in potential energy was just 1,000. If we had instead not used the ground as where the height is 0, because there's nothing particularly special about that. If we said the height was 0 here, well then my initial height is 20. My final height is 0, so my potential energy here, this drops out, and I'm left with a much simpler equation. And so my initial potential energy in that case would be 5 times 10 times 20, which is just 1,000, which is what we have right there. So what you choose to be your, where h is equal to 0 is up to you. That's the beautiful thing about the plus c. That constant allows us to take different heights. One other thought before we separate. Conservative forces and non-conservative forces, there's slightly different definition. A conservative force changes energy from one type to another. So in this case, it transferred, the conservative work transferred from potential to kinetic. So we started out with all this potential energy into kinetic, and then as it fell, it got transferred from one type to the other. A non-conservative force, something darker than that, this works. A non-conservative force transfers energy from one object to another object. So as the marker example, it has all this potential, I drop it, that potential gets changed into kinetic energy. When it hits the ground, that kinetic energy has to go somewhere, and that goes into, most of it into the carpet. What you'll find is that the marker and the carpet both heat up just a little bit. So it is possible just by smacking one thing, you will transferring kinetic energy into basically kinetic energy on an atomic level. And there's a video out there of cooking a piece of chicken by slapping it. It is an interesting video of the process that he goes through to create a machine that would slap a chicken so much that it would cook it. It was a student brought that to my attention last year. Yeah, I guess potentially if you do it enough, but it takes a lot. I don't know. Oh, thank you. Oh. Go ahead, what? Oh, for the lab? Yes, I have them somewhere. Actually, I have stuff to hand back too. Forgot out. For those who are still around.